What's up, PUBG gamers? Mr. Cully coming at you, and today we're going to be talking about stoichiometry, maybe the nerdiest sounding term you've ever heard besides my name, but it's hugely applicable, and you might not realize it, but it's going to make you a lot of money one day if you want to be an engineer. So, what is stoichiometry? Okay, stoichiometry is basically mixing chemistry with math. How so? Well, let me give you an example. I always go back to this airbag analogy. You're probably tired of me saying it by now, but let's say that you're an engineer working for Tesla, right? And you're trying to design a very, very safe airbag. Well, in order for an airbag to work, what do you need? Well, airbags work by igniting a certain powder called sodium azide. When you ignite this powder, what happens is it releases two products, and one of them is nitrogen gas, and that's what inflates the airbag. Well, if you're designing this airbag, you need to kind of know how much gas you want released. Otherwise, if you have too much, it's going to pop. If you have too little, it's not really going to be that effective. So how much is released depends on how much reactant you use. Well, you need to know how much powder you need per airbag in order to get a certain amount of gas released. And that's what stoichiometry allows us to do. It helps us figure out, okay, how much of substance A do I need to get out substance B, in a sense, all right? So it's kind of tying in all those balanced chemical reactions we've been working with now some math and some moles and some weird terms that we've been talking about, all right? So that's what stoichiometry allows us to do, and there's a lot of money to be had here if you want to be an engineer. So let's break this down. I came up with this flow chart because I think it kind of summarizes what you need to do in a very, very clear and visual way. So we're gonna keep going back to this flow chart, but this flow chart basically shows you, all right, you're trying to convert something, right? And whatever you're trying to convert, we're gonna call that substance A. So substance A is what we are trying to convert. Okay, you always start with what you're trying to convert, and maybe you're starting with grams of substance A, all right, or moles of substance A. Well, then you're going to ask yourself, okay, what's the problem asking me to find? Well, what if it's asking you to find moles of substance B, okay? Let's say you're given grams of substance A and you're asked to find moles of substance B. That means you're going to make two conversions, all right? That's what these arrows mean, two conversions to get there, all right? Well, what are those conversions? The first one's going to be finding the molar mass of A and using that to convert it from grams to moles. The second one's going to be the mole ratio, where you go from moles of substance A to moles of another substance. And so that's where we're using the coefficients of the balanced reaction, okay? This will make more sense when we do an example. I'm going to come back to this, but I wanted you to have a flow chart to kind of see, all right, where am I, what am I trying to convert? Where am I trying to end up? And this is going to outline kind of what you need to do and where you need to go, all right? So let's go over the front page of the worksheet that I handed out. Here we have the basic equation for formation of rust, and rust is iron oxide, Fe2O3. And the way that it works is iron gets oxidized with oxygen in the air, and it forms this kind of orangey brown kind of flaky substance. That's what rust is. So this is what that is, and we can see that we have coefficients. So this is a balanced reaction. These coefficients tell you something. It tells you that for every 4 moles of iron, you consume 3 moles of oxygen and you get out 2 moles of rust, okay? So those numbers out front, the coefficients tell you how many moles of that substance are being used up or being produced, okay? That's hugely important. All right, so let's look at number 1. It says how many moles of rust are produced if 3 moles of oxygen are consumed. Now, we could use the flow chart. We could do a bunch of math with this, but I want us to think about number 1 and number 2 conceptually real quick, all right? What's it asking us? How many moles of rust, okay, so we're trying to figure out how many moles of this thing, rust, are produced if 3 moles of oxygen are consumed. Well, we actually don't have to do any work at all because the equation's already set up for us. We don't really have to do any math. If 3 moles of oxygen are consumed, how many moles of rust are formed? And the answer is just 2. For every 3 moles of oxygen consumed, you get out 2 moles of rust. So this is just 2 moles. The equation tells us that right off the bat. We don't need to do any work here. We don't need to do any converting, okay? So this tells you, like a recipe, you need 4 cups of butter and 3 cups of sugar to get out 2 cookies. That's a bad cookie. But essentially, that's what recipes tell us, and that's what this is telling us as well, okay? Well, let's look at number 2. How many moles of iron, okay, so we're asked to find moles of iron, are consumed if 4 moles of rust are produced, okay? Well, this one's not as easy. It's not as clear cut, okay? We don't have 4 moles of rust up here. We have 2, okay? Well, think of it like a recipe. All right. If you wanted to double your output, if you wanted to double the amount of cookies, what do you have to do to the ingredients? Double them. Okay. So it says 4 moles of rust. Well, up here I have 2 moles of rust. Okay. So if I were to double this, 4 moles of rust, then I would have to double my ingredients as well. So 3 would become 6 and 4 would become 8, just like that. So now I can answer the question, how many moles of iron are consumed? Okay, we're looking at this. If 4 moles of rust are produced, okay? Well, if 4 moles of rust are produced, I would need to consume 8 moles of iron. Okay, it's all about ratios. It's just like a recipe. If you're trying to get this output, this amount of output, you need this amount of input. Okay, so we didn't have to do math for 1 and 2. It's basically looking at the equation, kind of figuring out what is it asking us to do. All right, what's it asking for? All right, let's do one where it's going to involve math this time. All right, so this is going to be a little bit more tricky. So it's the same type of question. We're doing the same conversion, except we're going to use math instead of thinking about it conceptually. So what are we asked to find? How many moles of oxygen are consumed if 7 moles of rust are produced? So we're looking at this guy right here and oxygen, which is right here. Okay. So 7 moles of rust, it's a 2 right there. So that's not really a clean conversion I can do. All right, so let's use this flow chart. Why not? What are we trying to convert? Okay, so what are we trying to convert? We're trying to convert 7 moles of rust to moles of oxygen, because it says how many moles of oxygen. That's what we're trying to find, and we're trying to convert 7 moles of rust to that. Okay, well, let's look at my flow chart. Substance A is what I'm trying to convert. Okay, well, I'm trying to convert 7 moles of rust. All right, so I'm trying to convert moles of substance A to, what's this? Moles of oxygen, moles of substance B. Okay, so I'm trying to go from moles of substance A to moles of substance B. Well, that means I only need to do 1 conversion, and that's the mole ratio. That's where I'm going to be using coefficients to tell me what I need to do. Okay, so here's how dimensional analysis works. You start with what you're trying to convert. All right, so in this case, it is 7 moles of rust. Okay, Fe2O3. You always start with what you're trying to convert. Then you're going to have some sort of conversion, like this. All right. Well, it tells me, this down here is telling me what I need to do to convert. I need to use the coefficients to convert moles of iron to moles of oxygen. Well, I'm going to be using coefficients, these right here. For every 2 moles of rust produced, I'm consuming 3 moles of oxygen. Okay, so that's what's going to go in this conversion. That's how I get from moles of this substance to moles of that one, or these numbers right here, this ratio. What does that look like? Well, if my moles of rust were on top up here, I know that moles of rust must be on the bottom down here for it to cancel. Moles of rust. How many moles of rust? 2, okay? For every 2 moles of rust, I am consuming 3 moles of oxygen, okay? That's what this ratio is. This is the mole ratio conversion. You're going to be using coefficients for a mole ratio conversion every time. All right, so that's what we're just looking at, these numbers. All right, so what happens here? Well, like I said, we put moles of rust on the bottom so that it would cancel out on top. What unit am I left with? I'm left with moles of oxygen. Is that what I want? You bet it is. That's what I was asked to find, okay, moles of oxygen. So I know my unit's going to be moles of oxygen. What's left for me to do? The answer is the math. 7 times 3, okay, multiply across the top, divide by the bottom. 7 times 3 is 21. Divided by 2 would be 10.5. So my answer is 10.5 moles of O2, oxygen gas, okay? So we only needed to do 1 conversion there. We went from moles of one substance to moles of another. Anytime you're going from moles to moles, you're just using these coefficients, okay? All right, let's take a look at another one. Oh, we need to find the molar masses of these first to kind of set the stage. So to find the molar mass, what do you have to do? Well, you have to find the weights of each of these, okay? How do you do that? You have to look at the handy-dandy periodic table. So the first one we're trying to find is iron, okay? So where's iron? Iron is right here, and we'll round that up to 56. It says 55.8, but we can round that up to 56. Why not? Make it a little simpler. So 56, and it's grams per mole. Oxygen is 16, but I've got two of them, so this is going to be 32 grams per mole. And then Fe2O3. All right, let's break this one down. Each Fe is 56, and each oxygen is 16. Well, I've got two iron, so that's going to give me what? 10. I'm not very smart. 112. And then oxygen here, I've got three of them, 16 times 3. What is that? 48, I hope. Okay. So from here, what are we doing? Okay, we need to add these together to get the final weight. So what's 112 plus 48? That'd be what? 160? Boy, if I screwed all this up. All right, 160 grams per mole. Okay. So we now have the molar masses of these. What does that allow us to do? Well, that allows us to convert between grams and moles of a substance. If I had 1 mole of iron, that's equivalent to 56 grams of iron. If I had 1 mole of oxygen, that's equivalent to 32 grams of oxygen. This is a ratio in and itself, too. It's given me the molar mass. How many grams of that substance are in 1 mole of that substance? So that's what we just found, and we're going to use these numbers here in a second. All right, so I'm going to write them down so I don't forget. So this was 56. This was, I already forget. Is that terrible? I'm like 25. 56, 32, and then we said this is 160, I think. Okay, we'll go with that. All right, so what is the question here? We are asked how many grams of oxygen are consumed if 5 moles of rust are formed, okay? Well, we're trying to go from moles of rust to grams of oxygen, moles of one substance to grams of another, okay? So we're starting with what we're trying to convert. We're trying to convert moles of one substance, substance A, which is whatever you start with, to grams of substance B, okay? What does that mean? We're going to have to do 2 conversions to get there. We need to go from moles of substance A to moles of substance B, and then using the molar mass of substance B, we can go from moles of that substance to grams of that substance. So let's do it, okay? You always start with what you're trying to convert. So 5 moles of rust, Fe2O3. Okay, and then we have a conversion here. In fact, I'll make this a little bit longer. Okay. Well, what's the first thing I need to do? I need to convert these 5 moles of rust to moles of oxygen using the mole ratio. Okay, my first conversion is going to be this mole ratio down here. Well, how do I do that? You look at the coefficients. For how many moles of rust do I consume moles of oxygen? For every 2 moles of rust I get out, I consume 3 moles of oxygen. Okay, so that's what I'm going to put inside these parentheses. For every 2 moles of rust, I consume 3 moles of oxygen. Okay, and what that allows me to do now is to cancel out my moles of Fe2O3. Okay, all right, so that's one of my conversions. Now I have one more conversion to do. I need to go from the moles of the substance, substance B, to grams of substance B. What does that look like? Well, in order for me to go from moles of a substance to grams of substance, I need to know its molar mass. Well, what's the molar mass of oxygen? Well, we found that out on the past slide. It's 32. So in every 1 mole of oxygen, it's going to be 32 grams of oxygen. That's what the molar mass tells us. For every mole of that substance, it's going to weigh 32 grams. So the moles of oxygen now cancel out. And what I'm left with is grams of O2. That's what I want. That's what I was trying to find. Grams of oxygen. So the only unit that didn't get canceled was grams of oxygen. That's what I'm left with. That's good. All right. So now all that's left is for me to do the math. So 5 times 3 times 32 divided by 2 is 240. So 240 grams of O2. Okay? And that's it. So you set up your conversions, you cancel out your units, and then you do the math. Bada bing, bada boom, you got your answer. For every 5 moles of rust that are formed, 240 grams of oxygen are consumed. All right, that's number 5. Take a look at number 6. How many moles of iron, here we go, are consumed if 300 grams of rust are formed? All right, so we're starting with grams of a substance. That's what we're trying to convert. And we're trying to go to moles of another substance. So we're going to be doing 2 conversions again. This time it's going to be a little bit different though. Grams of a substance to moles of a substance. All right, so the first conversion I'm going to have to do is molar mass. And then the second one I'm going to have to use the mole ratio using the coefficients. All right, so as always, we're going to start with what we're given. Okay, we're going to start with what we're trying to convert. 300 grams of rust. Fe2O3. Okay, and then we have a conversion here. And what's the first thing I need to do? I need to get these grams of rust to moles of rust. Okay, so I could do the mole ratio conversion. So I need to get grams of rust to moles of rust. How do I do that? The molar mass of rust, which we found to be 160 grams per mole. So what goes where? Well, I need to cancel out my grams. So grams is going to go on the bottom to moles of Fe2O3 up top. Okay. Well, for every 160 grams of rust, it's 1 mole of rust. That's what my molar mass tells me. Every 160 grams of rust equals 1 mole of rust. 160 grams of rust per mole. Okay, so that's where I get this from. Now I can cancel those units. My grams of rust cancel. All right, so what's my next conversion? I need to get from moles of rust to moles of iron. All right, fair enough. This is where I have to use the coefficients. So let me draw my next conversion. For how many moles of rust are how many moles of iron consumed? Well, for every 2 moles of rust, 4 moles of iron are consumed. I'm just looking at the coefficients here. Okay. For every 2 moles of rust formed, 4 moles of iron are consumed. So now I'm able to cancel out my moles of rust, and what I'm left with is moles of iron. And that's exactly what I want. So now I just need to do the math. Multiply across the top. So you got 300 times 4 divided by 160 divided by 2. And I got 3.75 moles of iron. All right, how do we get there? Well, I recognized what I needed. I circled my flow chart. I made a conversion from the molar mass, and then I made a conversion from the mole ratio. All right. Last one. This one's a doozy, okay? This is going to be the hardest problem that you're going to have to do. How many grams of rust will form if you have a 120 gram piece of iron that completely oxidizes? So we're going from grams of rust to grams of iron. We're going from grams of one substance to grams of another. All right. This is the one that takes 3 conversions to do because we're going from grams of one substance all the way over to grams of another. So 3 total conversions. So as always, you start with what you're trying to convert. You're trying to convert this 120 gram piece of iron to grams of rust. All right, so let's start it out. 120 gram piece of iron. And then I'm going to have some conversion here. Well, what's my first conversion that I'm going to have to do? The molar mass of substance A. So the molar mass of iron. I need to figure out what is the molar mass of iron, which I think we said was 56. Okay, so every 56 grams of iron is 1 mole of iron. That's what a molar mass tells you. It's how many grams are in a mole of that substance. All right. So now from here, I could cancel out my grams of iron and I could move on to the next conversion. What's my next conversion? I need to go from moles of iron to moles of rust. How do I do that? The mole ratio. Okay. The mole ratio. So let's go and set this up. How many moles of iron do I need to get out how many moles of rust? Well, for every 4 moles of rust that are consumed, I get out 2 moles of, every 4 moles of iron, I get out 2 moles of rust. All right, so let's put that in. Every 4 moles of iron, I get out 2 moles of rust. Pardon my handwriting. All right, so now I'm able to cancel out something else again. I can cancel out my moles of iron, and now I'm left with moles of rust. Well, I want grams of rust, so I have to do one more conversion. And the last conversion is going to be the molar mass of rust. So in order for me to go from moles of a substance to grams, I need to know its molar mass, which we said that rust is 160 grams per mole. All right, so that means that in every 1 mole of rust, it's going to equate to 160 grams of rust. And that was my final conversion. Now I can cancel out moles of rust. And what I'm left with, the only unit that didn't cancel is grams of rust. Grams of Fe2O3. Okay. Now I just need to do the math. So multiply across the top. 120 times 1 is 120 times 2 times 160 divided by 56 divided by 4. And I got 171.4 grams of rust. Okay. So this is as hard as it's going to get. Basically, you start with what you're trying to convert. In this case, it's 120 grams of iron. And then you got to ask yourself, where am I trying to end up? Use the flow chart to get you from where you start to where you want to go. Okay. And those things on the bottom tell you the conversions that you have to do. All right. So this was the front page of the worksheet. The second page, the back side. Go ahead and try that. And now having these skill sets with you, and let me know if you have any questions.